Now recording. So, hello everybody. How are we doing today?
Good.
Good. Wonderful.
Wrangling with container margins.
Ooh. Yes, yeah, that'll easily eat up your weekend, eh? Yeah. So, remind me how far we got in this class. We definitely got to the Bootstrap stuff. We did the grid system, yeah? Did we do the tables? No? Okay. Well, sounds like a good place to start. So, So, this is meant to be more of a demonstration of what Bootstrap is capable of. There's a lot more that you can apply Bootstrap to than we have time to get to in class, but a good example of how Bootstrap can make something that's normally very ugly look nice almost instantaneously is our old friend, the HTML table. So, if everybody could please open up your code editor of choice and follow along. Let's make a new HTML file. Bootstrap.html. There we go. Now, let's add our usual suspects. If you are using VS Code, of course, you can use the Emmet abbreviation. Head, end head. The head ends where the body begins, which is how it works in humans as well. So, just as, let me increase the magnification. Is this a good level of magnification, people sitting in the back? Can you see this? Is this good? Yeah? Okay. So, to review, the way that you enable Bootstrap for your HTML designs, if you don't have a server, is to use the CDN, Content Delivery Network, www.getbootstrap.com. There you go. Include via CDN, simply copy, paste, copy, paste into your head, and you have Bootstrap enabled. Very, very good. So, this is good. Now, we need a table. I'm going to create a div and make it into a responsive container, just because this should be like, kind of a default position when you're using Bootstrap, is to put some things in responsive containers. Div class equals container. There we go. Now let's make a table. 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 There you go. T-head, or fed, if you prefer. TH and TH. Video game. Genre. Popularity. And system. At this point, you folks should be able to bang out an HTML table reasonably easily. Like so. Now, can somebody give me a name of a video game?
Red Dead Redemption 2.
Red Dead Redemption 2. Red Dead Redemption 2. Genre? Country Western.
Sure.
That's a joke because that's normally a genre of music. How many people like Red Dead Redemption 2? 1, 2, 3, 4, 5, 6, 7. 7. Ah, that's pretty good. There we go. System, I think it came out for a bunch of stuff, right? System, everything. They backported it to Game Boy. Alright, give me another video game. Someone else.
Super Mario Odyssey.
You gotta put your hands up. Yes?
Super Mario Odyssey.
Super Mario Odyssey. Super Mario. You're just seeing if I can spell it. There you go. I think. Genre is Mario game. Mario games are their own genre. How many people in the room like Super Mario Odyssey? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait. I think that was 9. Genre, or sorry, system would be the Switch. Switch exclusive. Very good. Give me another video game. Yes? Half-Life 2. Not sure if it's hyphenated. I'm gonna hyphenate it. Genre. I don't know. What would you call Half-Life 2?
First-person shooter?
Yeah. FPS. Sure. Maybe / post-apocalypse. As opposed to Half-Life 1, which was a apocalypse. Popularity. How many people are in favor of Half-Life 2? 1, 2, 3, 4, 5, 6. Well, I'd have more sympathy, but, Valve hasn't actually made a video game in how many years now? They're more interested in sitting on top their dragon's hoard of earnings from Steam. Half-Life 2, that's a PC game. Although it did see release on the Xbox 360, I think, and possibly also the PlayStation. That's okay. One more video game. Yes.
Chrono Trigger?
Chrono Trigger. Ooh.
Classic.
Classic. I'm going to hyphenate that one as well. That is a big fat JRPG, that one. It almost typifies the entire genre, in fact. How many people are in favor of Chrono Trigger? I'm going to throw my vote behind that one as well. 5. That was the SNES, I believe.
Yep.
Yeah. There we go. And here's a free one. Factorio. Space age expansion, of course. Genre pollution. Yeah, because that game is all about pollution. Popularity. Anybody? I'm gonna modify it. How many people have heard of Factorio? 1, 2, 3, 4, 5, 6, 7. 7. There we go.
You bought votes.
Yep, that's what I did. System, Linux, only Linux, because it is the most Linux game that has ever existed. There are only 2 games more Linux than that, and that's Super Tux Kart and Super Tux, which are both Mario clones featuring Tux the Linux Penguin. So, oh, I should put Tux Kart on there. Anyway, it's okay, we have enough video games. So, we have our HTML table. We have some fun data. Let's see what it looks like when it renders by default, which of course will look absolutely terrible. Just irredeemably terrible, really. Even with the Bootstrap default fonts zhuzhing things up a little bit. There's this interesting property of default HTML tables where they set the width of the column based on the largest single entry in that column. So, but it doesn't quite leave enough space by default, so like, for whatever, like, you'll always end up with like, you know, these entries that kind of bleed into the next one, which is great if you're playing Frogger, but not so much if you're trying to read data, right? So, witness the magic in my fingertips as I enable Bootstrap for this really clunky looking table. All I need to do, class table, and ta-da! It's already instantly better. Not bad, right? Now that beats fiddling with like padding and margin on individual cells in a table, doesn't it? So this is just what default table gets you. You may be saying to yourself, well, that's kind of minimalist. I want more lines. In that case, you include it also in table-border. And you can have more lines if you wish. There you go. So, it's worth pointing out, right here, if you don't recall this from HTML, or if they never told you, the way that you include an HTML element in multiple classes is by providing a list of those classes separated by spaces. Spaces, not commas. Alright? Now, the general way that Bootstrap works, if you're trying to bootstrapify a component, you will include it in a class which is either like the same as the HTML element name or very close to it, right? Button is BTN, which is an abbreviation of button. You can then add additional visual options by including extra classes on top of the base class, which does the basic styling. Make sense? So, another couple of interesting ones that you can have. Table-striped. This is also a very useful thing to do if you're trying to read, if you're actually trying to read the data in the table. Having the table striped allows the user the end user to read a row out of the table without having their eye sort of drift into other rows quite so easily. It makes the table easier to read when you do it striped like this. There's probably a way to do it with columns too, if you're more of a columns kind of person. Ooh, columns. That's a video game we could put on our list. Anybody remember columns? You guys are you're too young. This is columns for the Sega Genesis. It's a gem swapping puzzle game where they fall down from the top in a very Tetris-like manner. But the thing about columns, you can't rotate the pieces this way. You can only swap them vertically. That's why it's called columns, because you always have columns. Columns. It's a good game. Anyway, it's fun. If you're into that sort of thing. Table hover. Table dash hover. Your cursor now highlights whatever row it's on. This doesn't add any like clickable interface or anything like that. It's just a visual effect, but rather a nice one. Now, let's talk about Bootstrap color theming. So, Bootstrap has a number of different, they want you to use colors semantically, which is a bit strange. But essentially, when you use the Bootstrap color system, you decide like what adjective is appropriate, and it gives you colors based on that adjective. So, for example, here is your color chart. We have default, which is just white, primary, secondary, success, danger, warning, information, light, and of course the best mode, dark mode. You can apply these to most Bootstrap components by taking the component name, putting a dash, and then specifying one of these attributes. So, for example, maybe I want to make our video game table a, which one should we do?
Let's do your factorial.
No, I mean the whole table.
Oh.
Like, what color do you want it? Did you just say danger?
Yes.
Are we making this a danger table? Danger! Oh! So dangerous. You can see that, like, it's a bit of an orangey, reddy, pinky, gray kind of color, which is a bit strange. But basically, this is in a consistent color theme with other dangerous components, right? One of the big advantages here is that we, not once did we have to open up a color picker, right? Now you are giving up some freedom and creative control over what color scheme your website is. The position that makes Bootstrap possible is kind of like, well, the color scheme probably matters less than you think it does anyways, you know? You can give up a little bit of creative control on the color scheme, and you reap the benefit of being able to program much, much faster and not spend all of your time fiddling with, you know, oh, what if I just increased blue by like 5, you know? So, you can do similar things with buttons. I'm sure we're all familiar with the default HTML button. If we include this in class button, suddenly it doesn't look much like a button because it's missing a border, but you can see it's still doing button-like things. However, what if I were to make this a danger button? So dangerous. There you go. There's a danger button for you. And you'll notice that it's taken care of quite a lot. It automatically changes the color of the font so that it's readable against the background color, right? But yeah. Buttons. Make sense? So, you can also do basic CSS stuff using Bootstrap classes if you wish. There's a whole series of Bootstrap classes for margin and padding. So you can see there's like no margin or padding on this button. Perhaps we want some. M-3 gives it a margin of, I believe it's around 30 pixels. I think what it's doing is, whatever your number here, it's like that times 10 pixels, and it applies it. M for margin, P for padding, right? Hopefully this makes fiddling with your container margins just a little bit easier. The other thing you can do is margin top, you know, top, bottom, left, right. You just add T, B, L, and R to do the different margins if you want to set them individually.
So is 0 also one of the properties then, if you want to like 0 margin it?
I think so.
Because on my screen, like there's a little bit of spacing like on the side. It's like barely noticeable, but it is there.
I don't know. There might be more complex interactions going on there. I'd have to take a specific look at it. But
when I got rid of it, there was like a slight horizontal scrolling bar, so I would avoid that.
Okay, yes. Yes, please. Yeah, so, you know, this is kind of, I guess you could say this is a marginal gain in productivity. But that is a little bit easier than setting up the CSS rule and all the rest of it. Now, you probably in certain circumstances would still want to set up CSS rules, particularly if you're trying to apply like some styling rule to everything, right? Like if your CSS rules are targeting elements, it's still very much more efficient to do it that way. As, you know, otherwise, you have to include M-2 in like the class of every single HTML element you want to apply it to. That is more work than just using a CSS rule, right? So, like, it's give and take. Once again, you find out what Bootstrap's good for, use it for what it's good for. The only way you find that out is experimentation. And then you use your other mechanisms for the stuff it's not good for. Use the tool for the job it's designed for, or maybe even not what it's designed for, but use the tool for the job it's good at. Right? Make sense? Any questions? Good. There is a way to apply a global color theme, which I always have to look it up, and it's not in the notes. This isn't in the notes. Bootstrap global dark mode. Yes. So this guy, there it is. Data ES theme. If you attach that to something reasonably high up, like HTML itself, dark mode. And let me get rid of table danger and button danger. You can convert the entire website all in one go to something like a dark mode. Make sense? That guy right there. So, that's a lot easier than going through each individual item and any local modifications you make to the color scheme, that will still apply. Like that'll override the global color scheme. Like for example, I still contest that this button doesn't look much like a button. So perhaps I want to throw button dash primary on there. Now it does look like a button, and it's overriding the dark theme. Make sense? Any questions? Okay. So, now I need to show you how to use some of the Bootstrap JavaScript enabled components. You will need to know this for assignment 2. There are a bunch of these sort of more advanced components. They require the Bootstrap JavaScript library. So essentially up to this point, we haven't really been using this second one here. All of the Bootstrap we've been doing so far would have worked if we'd left this out. This is importing some JavaScript. This is just importing the CSS rules, right? So there are a number of these components which require the JavaScript to be enabled, which do interesting and cool things. We shall do an in-class example of a carousel. Okay, I just want to note, if you Google w3schools.com's Bootstrap, what's the first hit? What's the first link? Bootstrap version 3. Be very, very careful when you're Googling. Make sure that you are selecting the right version for your reference material. Okay? So, Bootstrap 5. At the bottom here, if you scroll down a bit, you'll find a series of Bootstrap 5 components. These here are these are the Bootstrap 5 JavaScript enabled components that we're going to. You're going to have to use one of these during your second assignment. I'm not going to introduce the second assignment today because you're still working on the first one, right? But roughly speaking, assignment 2 is going to be solve for me a series of reasonably simple programming problems and embed your code for those into a bunch of components on the screen, right? So, for example, modal. Modal is a dialog box or pop-up window that is displayed on top of the current page. Open modal. Oh, that's a modal. So, essentially for assignment 2, you will have a bunch of buttons like that which open modals. Each one will have a small form interface for me to be able to send some data into your JavaScript function, and then the result is displayed in the same modal when I click go. Basic. Kind of input output kind of territory, right? Make sense? So this is a modal. Modals are good. Tooltips. Probably less applicable for our assignment coming up, but that's what a tooltip is. A tooltip is when you hover over something with your mouse, a little box pops up and tells you a description of the thing. Has anybody played Civilization 5 or later?
I have 6.
I only played a tiny bit, but it's on my laptop, so it got too laggy.
Yeah. If you have played Civilization 5 or later, they basically put probably 90% of the description you have to read to effectively play the game into tooltips, which I find very frustrating and bad game design actually. Because to know what everything's doing in that game, you have to do a lot of reading, and it's all in tooltips practically. It's anyway. Civ 4 was better, and I don't care who says otherwise. Peak of the series, in my opinion. Turn back on! Thank you. So that's a tooltip. Popovers are similar to tooltips, but they've got a bit more in them. So a popover has a header, and you can put some content in it. You can put general HTML components inside these things. You can see that the contents of the popover are interactable, so you can actually put form elements in those things. A little bit like a tool, it's like a tooltip, but beefier, you know? Toasts. Toasts are like alert boxes that are only shown for a couple of seconds. So the idea with a toast is that it's supposed to act like toast in a toaster. It's in the toaster, and it's like, ka-ching, like that. That's what a toast is supposed to be. Scroll spy is an interesting one. People don't usually pick it, but it's cool. So the point of scroll spy, you have a nav bar, and it highlights what you're looking at. So if I scroll down, you can see it's now highlighted section 2. If I continue to scroll, it's now highlighting section 3. Scroll spy. That's a cool one. I like that one aesthetically, personally. So, if you're trying to suck up when you do assignment 2, do scroll spy. So, now let's talk about carousel. Carousel is the one I'm going to demonstrate for you, and it's also one that you are not permitted to use on your assignment, because I'm doing it in class. So, carousel, or slideshow, is basically, you have a series of images, although they actually don't have to be images. You can swap the images out for something else if you want to. But, in general, they are images. And it just cycles through the elements. It cycles through the images periodically. You've got a Wow, W3 schools.
Nice advertising.
Like, good grief. Can I just thank you. That's now on my video. Good grief. You know the comments I'm gonna get on YouTube now? Good grief. Ugh. Sometimes I really hate Valentine's Day. So, anyway, where was I? Ah, yes. So, you've got arrow controls on the sides, you've got buttons for navigation if you want to go through it. A typical real internet example of the carousel that I usually indicate. Does anybody use Steam to purchase video games and that sort of thing? The opening banner at the top of Steam where they're trying to sell you games, that is also a carousel, right? What is it? Steampowered.com? Something like that. Yeah, there you go. This thing. This is also a carousel. And you can see it's got a little bit more going on, right? You can see that this one's not just the image, but it's got other stuff that gets thrown in as well, screenshots and all that kind of stuff, right? Idle Fest. Oh my goodness, what is even the point of idle games? Honestly. But anyway. Oh good, the ad went away while I wasn't looking. So, the way that you use the Bootstrap components, there are not many times I'm going to advise you to do this in my classroom, but this is one of those times. You go to W3 Schools, you find the example code, and you put that into your website. You find the example code right here. You perform a copy, and then you perform a paste. Now, this is going to look a little silly because the slideshow is going to occupy the entire width of the page. It's going to be very large. So I am going to quickly put this into a 2-column format with the table on one side and the slideshow on the other. Very easy, very quick. Within your container, create a new div. Class is row. Then make another new div. Class is column. This is a review of the grid system, by the way. After our table, and the div that is the column, start a new one. Div class is column. Then end two divs. There we go. Does anybody know if Notepad++ has an auto indent? Auto format? Auto completion? Well, I guess it's not worth the effort. So now, if we take a look, oh come on, what did I do wrong?
The image sources are relative.
But I wanted it like in columns side by
Oh.
side. Class row, class column. What if I put a breakpoint, manual breakpoint? Maybe it does want the actual images. Okay. We'll fix the we'll add the actual images to the carousel, and then we'll figure out that column business. So we need some images. Images like google.ca. What should we get images of? Any ideas?
The games we just listed?
The games there we go. All right, that's thematic. There we go. What do we even have? I'm gonna pick my favorites. Factorio. Space image. There we go. Save image. There we go. Not there, here. Factorio. Mario Odyssey. There you go. Save image. Mario. Avif. And what else do we have? Well, we might as well do all of them actually. Red Dead Redemption 2. There we go. Save image. RRD2. I guess that would be RDD. No, RDR. It would be RDR. Oh well. Half-Life 2. There we go. Oh, you gotta get the gravity gun in there. There we go. Half-Life 2. There we go. What else did we have? Chrono Trigger. There we go. The actual SNES box art. That sounds fantastic. There we go. Boom. Alright. So, if we take a look at the carousel code that we blindly copied and didn't even look at, let's go through a quick diagnostic to see what's going on. First, the carousel itself is a div. This is not surprising. We have our indicator dots, which are a bunch of buttons, which have been styled, of course. Those are existing inside of a div as well. Those are the buttons along the bottom. If we want to add more images, we will need to add more buttons as well. This is the meat of the item. We have the slideshow, the actual slideshow content. You'll see that the carousel items are divs. In this example, they are containing images. But once again, if you wanted to put other HTML components in there, it's just a div, right? So you can throw more stuff in there than just images. But you'll notice we have la.jpg, chicago.jpg, and nai.jpg. Which, of course, those are our image files. We may replace those with the images we wish to add. And once again, you are developers, you need to know the file extensions. So let's replace this one with factorio.png. Replace this one with chrono trigger with an underscore dot JPEG. hl2.hinge. There we go. And of course we need two more. One for mario.avif and one for rrd2.fif. There we go. So let's see how that renders, shall we? So there we go. Now you'll notice that our buttons are basically broken. But there are more slides accessible in the slideshow than there are buttons for them. But we also kind of locked it up. So we should put the rest of the buttons in. Here we go. 2 additional buttons corresponding to these additional slides. There we go. Bing, bang, boom. Restore. You can see we now have more buttons at the bottom. We can slide through all of our items now. Everything works. Any questions? All right. Now I'm going to see if I can figure out why the columns didn't work. So, just so you know, when I'm teaching a class and you're in the classroom and I encounter a bug or an unexpected outcome with my code, we are now in the most valuable part of the lesson, which is you guys getting to watch me try to debug something. Right? So, the first thing I'm going to do is I'm going to see about indentation, because the purpose of the indentation is to help us determine when divs are ending when they shouldn't be, and that sort of thing. So, div here on this line ends there, okay? And I'll try deleting that. Open up the new div. Select all the carousel code. There we go. There we go. That's all the carousel code. There we go, there we go. Div, div, there we go. So it seems that all of our divs are being ended correctly, so that's not the issue. The next thing I'm going to do is, well, there was a spelling mistake, but I think I just introduced that one. I'm going to check to see that I've spelled everything correctly to do with this. So, class container is working. That's good. Class row, that piece seems fine. Class column, that also seems fine. Class column, That also seems fine. So,
It works without the quotation marks?
yes. So, HTML attributes only require quotation marks if the thing that you're trying to assign contains a space character. However, just for the sake of paranoia, let's throw the quotes in there. Maybe that's doing something, maybe it's not. We shouldn't see any change. Yeah, and we don't. Good. So the next thing I'm going to try is to actually give myself an outline for these divs. Style, style, so I can see where they actually are. Div, border, 2 pixels, dotted white. Give it a margin of 2 pixels and a padding of 2 pixels. There we go. So this is kind of interesting. It does seem to think that this div, which is the div that contains the slideshow, is inside of the other div, interestingly. So let's give it another look, shall we? So table, table, div, div. What happens if we end another div here? Just out of curiosity. Okay. I'm going to have to use a slightly more extreme measure. So, if you're really stumped and you really just can't figure it out, right? By the way, has anybody spotted the error yet? No?
Is it doing close the table? Okay?
Did I not close? Oh! That'll be it. You know, you could have said something earlier.
I was nervous.
You were nervous. Well, yeah, so everything's inside the table. There you go. Wait, wait, wait. Sorry, the volume was too low. Let me try that again. There you go. All right. So, slash. There we go. The table is now ended. And it works. There you go. I can remove. Oh, don't apply, please. Please. I can remove the style tag now, because I don't need to see where all the divs are. And there you have it. By the way, this is not a paid or sponsored lecture for the games that are here. These are just games that we happen to like, collectively as a group. Although apparently, the one that we like the most is the Mario. So, any questions about that? Any questions about the use of carousel? Alright? And now for something completely different. Shall we dip our toes gingerly into the vast ocean of human excrement that is JavaScript? Yes. Trust me, by the end of this course you will see that I have not been hyperbolic. I may have said this before, but did you know that the guy who invented JavaScript apologized for it at a conference? That is true. That is a true fact. Okay, so we now come to the part of the course that we're all here for. Client-side programming. Up to now, we've not really been programming, we have been laying out documents. Now, we shall enter the world of a general-purpose programming language as it applies to web client-side development. So, did we discuss the difference between compilers and interpreters in this classroom?
I think you did, yeah.
Yeah, a little bit. Well, I won't belabor the point then. So, JavaScript operates inside of the JavaScript interpreter. The JavaScript interpreter is a sub-operation of your browser, right? So, you've got your operating system. The browser runs on the operating system. Well, technically the shell runs on the operating system. The browser runs on the shell. The JavaScript interpreter runs on the browser, right? And then your JavaScript code runs on the interpreter. So, this has a number of useful and beneficial effects. One, it is correct that JavaScript should be sandboxed. You don't want randos on the internet having access to your operating system directly. That would be a recipe for ultimate disaster, right? So, you can normally tell, you can tell a lot about a language by how complicated the hello world discussion is, right? In the case of JavaScript, I'm going to show you 3 different ways of doing a hello world, and one of them we can't even talk about this week. So, first and foremost, when we are working with JavaScript, we have a very valuable tool available to us in the JavaScript console. The JavaScript console can be accessed through the right-click menu, Inspect, Console, there she is. Wow, I kind of hate that. Just give me a second here. -6. There you go. So, this is your JavaScript console. Because this is an interpreted language, every single line of code that you can enter into a JavaScript file can be entered one line at a time into this interface, and it will execute the same way. Interpreters, right? Now I don't recommend doing it that way, but that's possible. Now, your basic print statement is the following. Console.log, hello world. Oh, that's a shame. There we go. Man, got a syntax error on the hello world. That's a little embarrassing. It's okay. You guys like me, I hope. So, actually I don't care. I don't care if you like me. All I care about is that you learn something. So, console.log hello world. This is the console that is referred to by console dot, right? Log is an operation similar to print. You'll find that the JavaScript console is actually pretty good in comparison to, for example, the Java console that you folks have been using embedded inside of IntelliJ. When you ask to view a data structure, it actually provides like a hierarchical, clickable interface for viewing that data structure. It's a little bit more useful than sort of a regular standard in, standard out based console, but that's okay. So, but let's talk about who this message is for, right? Although we generally call it the console, the full title is developer console, right? You may imagine if you're imagine your grandmother, right? Imagine your grandmother is using the internet somehow, right? You walk over and say, hey grandma, I want to show you something I learned in school. And then you open the developer console. Do you think that she will have the faintest idea what's going on? Probably not. Dear sweet lady, but she will have no idea what's going on. This thing is for developers by developers. It's for everybody in this room, but nothing that you print here can, should, or will be seen by your typical end user. This is not how you print information to a user of your website. Does that make sense? That being said, very useful for development work. Hello world number 2 is the alert box. Now, alert boxes happen to be terrible user interface design. They are atrocious. Please try to avoid using them whenever possible. That being said, here's how you do it. Very simple. Alert, hello world. This page says hello world, which is all well and good. Now, if you spam these, the user will get extremely frustrated, right? This is basically, you have avoided the issue of having to put this information into your website properly, right? This is like your kludgy workaround. The only time I've ever seen an alert box used where it hasn't been completely terrible is like, you're filling out a web form and you forgot to fill in a field, and then when you click OK, it pops this thing up and say, hey, you forgot to enter your address, stupid, right? Something like that, maybe. But even then, there are better ways of handling it. So, alert boxes. Alert boxes have fallen out of favor in the same way that pop-ups have fallen out of favor. Anybody remember pop-ups from the 90s? Yeah. Many of you will have been raised in the post-pop-up apocalypse. So basically, it used to be the case that you could very easily spawn a new browser window using JavaScript. So this was often done for ads. An ad will pop up in a new window over top of your entire computer interface, and you have to, click the X and make it go away. And like probably 110% of the time, those ads led to viruses, anyways, if you accidentally clicked on the window, right? And it was very, very highly possible to just spawn a million pop-ups, and normally this was taken in the 90s to be an indication that your computer was infected with viruses if you got pop-ups all the time. But there's a very good XKCD cartoon on this subject. It's a Venn diagram. Problems caused by viruses. Problems people think are caused by viruses. Notice that there's no overlap in the Venn diagram, right? So anyway, so don't use alert boxes. There is one interesting thing about alert boxes that they do actually, though. Have you noticed something about our website in this whole time I've been talking, since I opened up the alert box? Something has changed. Anybody have a guess?
It's paused.
Frozen.
Yes, it's frozen. So the alert box shuts down JavaScript until the OK button is clicked. It also shuts down page re-rendering until the OK is clicked. So for example, if I close the inspector pane, you'll notice that the page does not re-render to the new width until I click OK. And only then does it re-render the page. So the alert box can also kind of be sneakily used as a developer to put a breakpoint in. It's a little tricky to use them as breakpoints, but it's possible to use them as breakpoints. What you'll find out if you start using alert boxes as breakpoints is that there's a lot more going on inside of the browser than you think there is. When something is queued for rendering and when it actually renders are two different points in time for the browser. So pausing it, sometimes does, sometimes doesn't have the effect that you think it will. At any rate, any questions about that? So far, so good. So far, we haven't done anything. Pardon me. So far, we haven't done anything that interesting. So, the third way of doing a hello world is to manipulate the website itself to insert information into it. This is something that we will not discuss until we talk about DOM manipulation, right? Which is a topic that is upcoming. We have to talk about basic language constructs first, right? So, basic language constructs then. I know it's coming up on the break, but we're gonna let's do a little bit more and then we can have the break. So I am going to go through. I'm going to go through a bunch of basic language constructs and rules. I am going to demonstrate to you that they work mostly the same as you would expect them to, but that there are a few important exceptions to how things work in JavaScript that you must know if you're going to use the language. All right? So, let us start with the fact that JavaScript is a dynamically typed language. Dynamically typed. Does anybody, okay, first, can anybody tell me another language that's dynamically typed? You've used one before. Yes?
Python?
Python is dynamically typed. That's absolutely correct. Python is dynamically typed. PHP is dynamically typed. JavaScript is dynamically typed. These are all interpreted languages. Dynamic typing is an interpreted language thing. Right? JavaScript is statically typed. So the opposition you have is between statically typed languages and dynamically typed languages. So what does it mean to be dynamically typed? Does anybody have any idea? Yes?
It's like where a variable can have like multiple types, something like that.
Well, in a sense, a variable cannot have multiple types at the same time, but it may have multiple types over its lifespan. Right?
Yeah.
So, for example, you couldn't say this variable x is simultaneously a string and a float. That's still nonsense, right? But you can say, let x equal 5, and then on the next line, x is equal to potato. This does not constitute a syntax error in JavaScript. It also is not a syntax error in Python. You may reassign values to variables of different data types. Now, the advice that I usually give to students in order to, it's kind of a mental hygiene thing, actually, in my opinion. Although you are working in a dynamically typed language, my advice to you is that you still think like you're working in a statically typed language, right? Just because you can do something doesn't mean you should. Your variables can get into very strange states if you are constantly playing with the data type inside of them. I don't recommend it. Variables are cheap. If you need a variable to be a string, declare a new variable, you psychopaths. It's not 1970 anymore. You have more than 1 kilobyte of memory. All right? Just make a new variable. All right? So, it's okay. I didn't mean to call you all psychopaths. Although, there is a certain when it comes to code minimization, it does border on psychopathy at some point, But you shouldn't. Everybody in this room should not worry about code minimization. You are not there yet, right? You should worry about your program working. That's what you need to worry about right now. I don't care about you must write your program in in under this number of lines of code. I don't care about that. Dave Gilbert cares about that, and when you see him later on in later semesters, he's going to put you through that. But for here and now, just write me a program that works. All right? So that's bad practice. Don't do it, basically. That is an anti-pattern. So that's dynamic typing. In contrast to Python, JavaScript is also weakly typed. You're weak, JavaScript. Does anybody care to guess what weak typing means? Any takers? Shall I just tell you then? So, the essence of weak typing boils down to the fact that in JavaScript we have not one, but two equality operators. We have double equals, but we also have the dreaded triple equals. Now, this is already deceptive. We know and love double equals from Java, right? Of the two of these, the closer in function to equality as it exists in Java is this one. Triple equals is strict equality, strict or strong equality. Double equals is weak equality. So what is the difference between strong and weak equality? Weak equality will attempt to equate things of different data types. Strong equality considers different data types to never be equal to each other. Under weak equality, things of different data types are sometimes equal to each other. Under strong equality, things of different data types are never equal to each other. That's the difference. So, for example, five is weakly equal to 5. The string is true. So, oh, and by the way, JavaScript doesn't have integers or floats. It has a data type called number. Number. It's taking integers and floats and cramming them into one data type and calling them numbers. That's what JavaScript does. So do you see why that guy apologized for it? 5, the number, is weakly equal to the string containing the character 5. It is not weakly equal to the string containing the number 4. Under strict equality, this is not true. Does that make sense? Recall, or remember, or perhaps understand this because I'm telling you. Of the two of these, Weak equality is the equality that JavaScript likes to use by default. There's a reason that they put weak equality on the double equals, which everybody knows from every other language, right? JavaScript prefers weak equality. I find this bizarre, but I am a trained logician. Let me show you something, one of the things that bothers me about this language, all right? So, has anybody here heard of the transitive property? Transitivity. So, when you have mathematical operations, there are certain key properties of them that make them what they are, right? One of these is transitivity. See if you can follow this, all right? This is some pretty highly advanced stuff. Hopefully everybody in the room can understand what's going on here, but transitivity states that if A is equal to B, follow me so far? A is equal to B, and B is equal to C, B is equal to C, so far so good, then that implies, anybody? A is equal to C. This does not hold for weak equality in JavaScript. This is a property which defines equality, and it doesn't hold for weak equality in JavaScript. I can easily demonstrate this to you. 0 is weakly equal to 0 as a string. 0 is also weakly equal to the empty string. Anybody care to guess if the empty string equates to a string containing the character 0?
That was false.
False. So, in this case, 0 is B here. But yeah, so under weak equality, basic laws of logic do not hold. My recommendation, once again, when you're in a language like this, program it as if it were Java, all right? You should have a preference for strict equality. Now, this poses a few problems. So in JavaScript, we have operators for greater than and less than according to weak equality, but there is no equivalent strict greater than or strict less than. These do not exist. Although people will occasionally assume that they exist on a test, and anytime I see that, I'm like, oh, I wish it did too, you know? But yeah, so there's no strict greater than, strictly less than, but using strict equality. The best you have is that you have strictly not. That exists, but other than that, these are the only two strong comparison operators. Right? So, JavaScript. Yay. Any questions? You have a question? No? Okay. Any questions? Yeah, don't worry. It's gonna be a fun ride. Okay, so I think at this point in time, I am going to declare our 15-minute recess. Please be back here by 11:40. Thank you. For the benefit of all of you watching, that's what I've been doing on the board. There you go. Use your anger. So, it's okay. Hate can be a useful emotion, but only when it's directed at JavaScript.
Okay.
So now that we've talked about these very, very important principles of how typing is bad in JavaScript, I would now like to go through more language constructs. So you may notice right here, I am using the let keyword to declare a variable. You actually have two options for, well, three, but technically the third one isn't a variable. You've got let, you've got var, and you've got const. That's a cursive Z for any of you Zoomers out there, by the way. So, let, var, and const. You will notice not one of these suggests a data type. This is a dynamically typed language. Unlike Java, we do not declare our variables with a data type. The data type is implied by whatever we initialize it with, essentially. So, in Java they have done scoping with you, right? Local versus global scope? A little bit? Did they do that? Did they do that in Python?
Yeah.
Oh, hopefully they did that somewhere. You guys need me to go over local versus global scoping?
Local is basically within the code block, can't be accessed outside of it, and the global we can do it from anywhere, right?
Yes, that's a decent summary. So the idea behind local and global, it's kind of best expressed in functions, right? So if you have a function, let's say you have a function and you declare a variable inside of it, right? In Java, that is a variable local to the function, although in Java they're called methods, of course. So it's local to the method, right? Within the context of the Java that you folks have done so far, the most global thing that you'll have seen is an instance variable of a class, right? The class instance variable is accessible to any method inside of the class. With respect to the methods of the class, the instance variable is global, right? But, because Java is a well-structured language, that's actually, that's not quite the same thing as being a global variable in the truest sense. The closest that Java gets to having global variables is having static properties of static classes, right? Don't worry, you'll get there. I'm not gonna get into Java too much for you guys, right? But basically, within Java and within most languages, it's kind of pardon me, if you're taking a phone call, would you mind doing it in the hallway? Thank you. This kind of dichotomy between global and local is actually a lie. It's a white lie, but it's still a lie. How you should actually think about scope is most local to least local, right? If you think in sort of binary terms, local versus global, you exclude the fact that there are a whole bunch of contexts between global and local which can still be used, right? And which are still important. You know, to a Java program, an instance variable is global with respect to a class, right? Static variables are global with respect to the whole program. But everything inside of a Java program is local with respect to the operating system, right? And the operating system is local with respect to the hardware, right? So, like, there are layers. Both Java and JavaScript use a scoping mechanism called block-level scoping. So, this means anytime you have a code blocks being defined by curly braces, right? A code block opens with an opening curly brace and closes with a closing curly brace. That is a code block. Local contexts can be determined on the basis of code blocks. So, for example, if I have a loop, while a let x equal 4, while b let x equal 5, and then I asked to print x. You can do the same thing with if statements. Here's my question to you. What is the value of x? How many people think it would be 4? How many people think it would be 5? How many people aren't paying attention? The 5s have it, right? When we use x here, it examines scopes and it will pull x from the most local scope that it exists in, right? Another way of saying this is that this local definition of x is overriding this less local definition of x. Now, this is still not a global variable in sort of the true sense of the word global, right? It's still bound inside of this program. It's still local, but it's less local than this one in this context. Does that make sense? So that's how scoping actually works. So the difference between let and var is that let binds to the local context, where var binds to the global context. And global in this case means to the JavaScript interpreter session itself, right? So you can think of the interpreter, sort of the main execution of the interpreter, as being a context in which variables exist. Var binds to that context. Does that make sense? So basically, this context here, when I'm operating inside console, this is the global context. This is where variables get put if I bind them with var. Does that make sense? Good. So, const, I believe const also binds to the global scope, although I should probably look that up. JS, is const local or global? Block scope, local variable. Oh, okay. So they are local. Alright, never mind. So, const stands for constant. Constants are variables which have read access but no write access past the point of their creation. So if I say const z is equal to 15, then I always have the number 15 accessible through the letter z for that entire context. So a thing that you often use const for is if there are some things that you'd like to set at the top of the file that you'd like, parameters of like the whole thing, right, that you'd like to set at the top, const is what you would use it for. Right now I'm sort of grinding out an update to server side where I'm doing some JavaScript inside of Node.js, and that's been a very interesting intellectual journey. There, you have to tell the server what port number to listen on, and that gets usually put at the bottom of the file, but it's like important configuration information, and we generally put important configuration information at the top of the file. So the typical thing to do is to declare a constant telling us what port number the server is listening on, and then that constant is used later down on in the code where it actually sets up the server, right? That's kind of a typical application of a constant, right? Does that make sense? Good. So, have they discouraged you from using global variables? Yes. Did they tell you why, or did they just say, do as I say? Don't use global variables. What explanation did they give you? I'm interested. If anybody recalls.
I don't think they really said anything, but from my understanding, watching like videos of other developers like on YouTube, they say like if you're dealing with global, like if there's global variables everywhere, you never know like if you're doing something that'll overwrite.
This is true. So let me lay out some more abstract design principles for you. It is true that you should avoid the use of global variables in general. However, I'm not going to say never use them, and I'm not going to say there is no purpose in them, right? There are certain types of operations you can only do if you have a global variable, right? They tend to be overused by novice developers, right? Because they kind of solve a problem for you, which is properly understanding data flow through functions and methods, right? So when you write a function, right, you are saying, given these inputs, perform this calculation, return that output, right? That is what a function does. Every single global variable is implicitly an extra input and an extra output of every function, right? Because a function can take input from a global variable, a function can write output to a global variable, right? In addition to its return value. So, in a lot of ways, and you folks will understand this once you take the software testing course, right? The complexity of testing a function is directly related to how much input it has, right? It's much easier to test a function which takes 2 integers than a function which takes 12 integers, right? And this has to do with, the search space of, basically, you have this concept of input state, which is like every possible combination of every possible value of all of your inputs. this is called your search space or your input space. It's vulnerable to a thing called the state explosion problem, right? So basically, for every bit of input that you add to your function, you double the number of states that you have to deal with, because binary, right? So, for example, you know, let's say I'm writing a function which takes one 8-bit integer, right? So you have 2 to the 8 possible combinations. What if my function takes 2 8-bit integers? You have to multiply that. So that becomes 2 to the 16 possible values. Now, 2 to the 8, anybody know? What's that? 256, right? I forget what 2 to the 16 is. I should know, but I don't. There it is. This one is 65,536. So you can see, going from 8 bits to 16 bits of input has increased the number of states that we have to test if we're going to exhaustively test something by, 2 orders of magnitude. That's a big increase, right? And consider that 2 to the 16 is a short integer under modern language definitions. That's kind of where the smallest amount of input you could possibly get starts, right? If you're taking strings in, good grief, the amount of time that it would take to exhaustively test half of a tweet is, if you could test 1 billion test cases per second, it will still take you much longer than the universe is old to test all of those cases. This is what's known as the state explosion problem, and it's the reason that testing cannot guarantee software is correct. Because there can always be a test case hiding out somewhere that you didn't test that breaks the system. Right? So, by using global variables, you are adding a bunch of implicit inputs to the function and increasing the number of possible input states and making it more difficult to test it to make sure that it's correct. That's like a high math reason that you want to avoid global variables. Another reason is anytime a function writes to a global variable, we call that a side effect, right? Side effects should be avoided, right? And the reason that side effects should be avoided is that program state now depends on what functions have been called, how many times they've been called, and in what order, right? That also makes it very difficult to reason about program correctness. Now, if you write your functions in such a way that it doesn't matter how many times you call them or in what order, it doesn't affect program correctness, that's a much easier program to test. But if the functions have side effects, it becomes a lot harder to determine if your program is correct. Does that make sense? So those are some reasons to not use global variables or to avoid them if you can, right? That being said, you will probably still see me use them. JavaScript is kind of such a bogus language anyways that you kind of have to use them to an extent. But in general, if you have the option, you should favor let bindings over var. Okay? Make sense? Any questions? Alright. So, moving swiftly on. Let's talk about if statements. If statements work the exact same way in JavaScript as they do in any other language. They are syntactically most similar to Java, but aside from this business here, where you have to worry about the expression that you're putting into the if statement, the if statement semantics themselves are unaltered. Okay? So if statements are good. Number 2, while loops and do while loops. Did you guys forget that do while loops exist already? No? Poor do while loops. So while loops and do while loops also execute in JavaScript the exact same way that they do everywhere else. So you can rely on your knowledge of while loops in JavaScript. For loops. For loops in JavaScript follow the Java convention, which is actually the C convention, rather than that weird thing that Python does with for loops. Alright? We are in normal, regular, 3 things in the guard for loop land, not in weirdo, like it's actually a for each loop, but they called it a for loop in Python land. Okay? I'd like to, okay, alright. I'd like to do a demonstration of for loops, but it occurs to me that I haven't actually shown you how to put a JavaScript file and attach it to your HTML. So let's do that first. It's very simple. All JavaScript occurs using the script tag. So, script. We then specify a source, name the file, myscript.js, and then close it. You have to leave the gap even if you don't put anything in it. That's just the way HTML works, I guess. So we can now make a new file. Save this as myscript.js. There we go. And now the contents of this file will be loaded and executed into the browser when the script tag is encountered. That is a very, that's a subtle detail which is very important. Alright? Console.log hello. There we go. This is very important to understand. Hello. So, can anybody tell me how HTML is loaded into a browser? How do browsers load HTML? Is it all at once or one line at a time? How many people think that HTML files are loaded all at once? How many people think one line at a time? How many people have no strong opinions on the subject? So, the majority of the class is right. It is appropriate to not have a strong opinion on the subject. No, I'm kidding. The majority of the class is right. The browser loads HTML files one line at a time. This is actually how it loads everything. So, the browser executes JavaScript blocks as they are encountered in the HTML file. So, for this file, the browser first loads the HTML tag, then the head, then the link, then that script. Then on line 5, it loads this JavaScript, it pauses loading the rest of the file, executes this script, and then only when this is finished does it load the rest of the file. Does that make sense? This has implications. If your JavaScript requires a reference to anything here, it must wait until the entire file is loaded before it goes after references to things in the page. Otherwise, if you just ask for, that button, on line 5, this button hasn't been loaded yet. On line 5, trying to access that button produces a null reference, which is, of course, an error. Except, of course, in a good language it would be an error. In JavaScript, it just doesn't do anything, and it doesn't even give an error. So, yeah. We'll hit this point a few more times when we get into DOM manipulation, but for now, just please file this in your mental filing cabinet. JavaScript is executed as it is encountered. Okay? Sound good? All right. So, in my little JavaScript script, I'd like now to demonstrate the difference between let and var bindings using for loops. So a for loop is very similar to how you find them elsewhere. The primary difference is in the manner of variable declaration. Of course, in Java, we would need to say that I is an integer, but in JavaScript, we don't declare variables with data types. We use let or var. This is an example of let. Console.log I for var j is equal to 0. J is less than 4. J plus plus. Console.log j. Well, actually, let me make that from 10 to 14 so we can tell the difference. There we go. Reload the page. You can see we get 0, 1, 2, 3, 10, 11, 12, 13. For loop. Here's an interesting thing though. If I ask for j, the variable j, j's value is now 14. This is the value of j that broke the loop, right? J is fully accessible in the console. I, on the other hand, is an uncaught reference error. I is not defined. Now, we should be grateful. We should be grateful to the JavaScript interpreter because this is one of the rare occasions where you get an honest-to-goodness error message. If you try to read from a variable that doesn't exist, it will complain at you. All right? I does not exist in this context. Why?
You declared it with let, which is local, and it
Yes,
appears.
and the question is, local to what? Right? This isn't inside of a function. The for loop exists in the global context. However, recall, JavaScript uses block-level scoping. This block counts as a block for block-level scoping. The let is binding it to the inside of the loop. So once this loop is finished, I is deallocated, it does not exist anymore, and is therefore no longer accessible. Does that make sense? Any questions about that? Okay. Good. Now, unfortunately, for completeness, we have to talk about for each loops in JavaScript. I don't really want to, but for completeness we have to. So, for each loops in Java, right? You have, if I recall, you declare like int x colon and then like a data structure. I believe that's Java, right? Python, the default for loop is a for each loop. Feast your eyes. It at least calls it a for each, but that don't look like no loop to me. So, for each loops are not a primary language construct in JavaScript. There's no like loop statement. What a loop is it's the application of a for each method to a data structure type. Oh boy. And in fact, anybody know what this bloody thing is? That is a lambda function, my friends. We're actually gonna have to learn these actually, but a lambda function is basically an inline function declaration. So this is defining a function. You know it's a lambda because you see this arrow here. This is a list of arguments. This is the expression that executes, right? So basically, this is a function taking one argument, mapped to element, and then it console logs it. So what this is actually doing, for each element of array 1, take the element, print it to console. Like it doesn't read that badly, you know, but this is not a for loop in any sort of way that you may think of them, you know. What this actually is, they shouldn't even call it a for loop, for each loop. This is a mapping function. Like there's a term for this. This is a map. Oh man, so bad. So I don't recommend using them, at least for now, at least until we discuss what the bloody hell a lambda function is, right? I don't recommend using these until you've got a little bit more JavaScript under your belt. There's nothing that thing can do that you can't do with a for loop. Like a regular for loop, right? There's nothing you can do here that you can't do with a regular for loop. I will default back to my original position. JavaScript will go more smoothly if you pretend it's Java, right? So, terrible. For each loops in JavaScript. Any questions?
So what was the point of them making the method to begin with if they already had the for loop added to this?
Well, because other languages have for each, and like they somehow for each loops weren't included when JavaScript was originally designed. Adding a new construct like that is like just a terrible idea. Like, you know, like you want to keep that kind of stuff to a minimum. So this looks to me like a kludgy workaround to try to include that language functionality in the language. This is called ad hoc language design. All right? You know what ad hoc means? It means
Make it
after
as
the
you go.
Yeah, basically, it's like after the fact, right? This was added after a decision to not include for each loops properly and then put them back in again using like a back channel, using a method on a collection class rather than do it properly, right? So yeah, do you hate JavaScript just a little bit more now? Hopefully, do you feel the anger welling up inside of you? Hopefully. So another thing that JavaScript really likes is to like take something like that, make this a code block, and then like just do a bunch of lines of code, and then you have to like, you'll find in JavaScript a lot of your like code blocks end not only with a curly brace but also with round braces, because it's actually inside of another statement. You'll find this as we go along. Any questions? Switch cases are basically the same as well. The big difference with a switch case, though, between Java and here, is that which of the two of these do you think switch case uses?
The bottom one?
You would think, right? But no. Switch cases use weak equality by default. Okay. Okay, so now let's talk about error literals. All right? So, JavaScript is a language that likes to minimize the number of errors that it shows you, because it thinks that you are a child and you can't handle an error, right? It's like, errors are hard, why is my program broken? It's like, because you're a bad programmer. You wrote a bad program, that's why it's broken. But JavaScript will do everything in its power to take bad programs and to execute them anyways. One of the ways that it does this is it carries error states, certain error states, through the code, through calculations, as literals. You guys know what I mean by a literal? You guys know what literals are? Oh, so 5 is a literal. Boolean true, Boolean false, those are literals. Any string that you've written between quotes, that's a literal. Alright? Literal, it just means it literally is what it says it is. It's not a variable, it's a literal. Right? So, in JavaScript, there are 3 of them. One is like explicitly an error should be an error message, but it's just an error that gets carried through calculations. The others are a little bit more, they have different purposes. But you have undefined, NaN, which does not stand for a delicious form of bread that you eat with curry, but not a number. The kind that you have with curry has 2 A's, of course. And null. You have a null type as well. Right? Now, each of these equate to each other under weak equality. They will also equate to 0, the number 0, and the empty string. These are all the same thing according to weak equality, which is stupid. Right? Under strong equality, they are different things. So, yeah, we're gonna come to know and love these stupid things as well. So, let me just take a look at the notes to see if I didn't forget anything. Oh, okay. So, on the subject of quotes, we are in Python land. Double quotes, single quotes, both mean the same thing in JavaScript. Okay? Semicolons are optional, but recommended. There's only one place where you actually are required to use a semicolon, and that's if you're putting more than one line of code on one line in a file, like let x equals 4, let y equals 7. If you don't include this semicolon, then it will consider this to be part of that expression, and therefore that would be a syntax error. So if you want to put more than one line of code on one line, you must separate it with semicolon. Semicolon is actually correctly understood as a line termination operator. Alright? Make sense? Good. So your math functions are inside of the math object that's imported by default, that's part of the prelude. So you have access to random, round, pi, trigonometric functions. All of the stuff in the math library is just there for you inside of math, okay? And it's the same stuff as, like, the math library in JavaScript has the same functions in it as the math library in Java, as does the math library in Python, because, here's the kicker, folks, all of these things are just wrappers for the C standard math library, which is in the bloody kernel. Alright? So they're all calling the same kernel functions in the, under the hood, so that's why basically all programming languages support the same math operations. Make sense? Good. So, how are we doing for time? Oh, we got loads of time. All right. It's great when you don't have the stupid survey consuming the first 20 minutes of class, eh? Functions. JavaScript has drawn a fair amount of influence, it has allowed itself to be influenced by the functional programming paradigm. So, pretty much all of the programming languages you're likely to ever use are going to be in the imperative/object-oriented paradigm. There are other languages in other paradigms. The typical example of, like if you were to pick a functional programming language, that language would be a language called Haskell. Has anybody heard of Haskell? A little bit? I'm impressed. It's basically a language for egghead academics mostly, such as myself. So, the Haskell programming language looks like this. Can I get it? There you go. This is what Haskell looks like. Alright? Basically, Haskell is a functional programming language, so everything is a function. In object-oriented, everything is a class or an object. In functional, everything is a function. It's based on lambda calculus, which is a different mode of calculation than the Turing machine. So, basically, these all define functions. You say what the function takes in and what it outputs. it's a little bit on the complicated side, and but it accomplishes quite, like, Haskell code is very, very, very dense in terms of the number of, like, CPU operations that each line maps to. The equivalency is like, you get like 20 or 30 lines of code in any other language out of one line of Haskell, roughly speaking. But everything is a function. Everything that, like, when you use a function, you can pass functions into functions as arguments to functions. You can also get functions out of functions as the return result of functions. This is functional programming, right? Everything is a function, including the arguments to functions and their return results. Haskell considers a number like 5 to be a function that takes no arguments. So you're saying, why is he talking to me about this? Can we not just do the functions, please? So, when you use functions in JavaScript, functions are first-class language elements. Functions can be passed into functions as arguments. Functions can be the return results of other functions. Functions can be assigned to variables, right? JavaScript does not think of a function as being a function or a method. It thinks of it as being a reference to a function. We shall see how this works. But first, let's write a simple function in our script. So go to your scripts and write the following. Function add 3 x, y, z, return x plus y plus z. So you will notice, hopefully, functions here look and feel a lot like functions in Python, right? If you take the keyword function, replace it with the keyword def, take the braces out and replace it with indentation and a colon, like if you squint at this, this looks like a Python function, right? Yes and no. Let's try to use it. So, I want you to pay attention carefully to what's going on in the interpreter. The interpreter will show you the calculation results of partially expressions that you've only partially typed, right? So, add 3, not a number, interesting, 1, 2, 3, 6. But here's a question. When I add 3 and I provide 3 arguments, I get 6. I get the expected result. If I undersupply the arguments, if I do not provide as many arguments as are requested in the method, in the function, I do not get an error. Well, I do not get an exception. I don't get the red box and the little x, right? What I get is not a number. Strange. Because of dynamic typing, we can use this function on things other than integers. So, for example, I can throw a string in there. So if I throw a string in, I get 1, 2, 3. The plus sign on strings means concatenation. When you concatenate anything with a string in JavaScript, that forces the other thing to become a string. This works the same way that it does in Java, right? So this function still works on strings, even though perhaps it shouldn't, because it's called add. Add implies arithmetic. But nevertheless, let's see what happens when we undersupply this one with arguments. 1, 2, undefined. So what can we conclude about the value of arguments which have not been provided during a function call?
So it'll just default to whatever closest data type and tries to perform the operation?
Yes. Well, it defaults to one thing specifically. It defaults to the undefined literal. So when you don't supply enough arguments, it inserts undefined into the missing arguments and then just keeps processing anyways. What does Java do?
You get an exception?
That's right. Java slaps you in the face and says, do it properly. Have you guys talked about polymorphism in Java? Have you heard the term polymorphism?
You mentioned it. We haven't really covered it though, but it's
Okay.
supposed to be like the object behaves differently depending on what situation it's being.
This is a form of polymorphism. So polymorphism, poly meaning many, morphic meaning shaped, right? Polymorphic. Basically, the thing has different behavior depending on how it's been called, right? So depending on the number of arguments, I get different outcomes. Depending on the types of the inputs, I get different outcomes. So now, we can tease this one apart a little bit. So we know if we add 3 passing only 1, the other 2 are undefined. It's being coerced to arithmetic addition now because this is no longer a string, that is a number, not an integer, it's a number. So what we have there is 1 plus undefined plus undefined. Anybody care to guess what 1 plus undefined is? One plus undefined is not a number. Right? And not a number plus not a number, or not a number plus undefined is also not a number. So that's where the not a number that we got earlier came from. It's the result of trying to perform an arithmetic operation on a thing that is not a number. Again, Java would give you an error message. It would slap you in the face and say, do it properly. But JavaScript is like, oh man, no, it's fine. I can do it. I can work with that. Not a number. So you might be asking yourself, what do I do? How can I make sure that my functions are not being abused, right? How is it that I can actually do this? Well, there are 2 ways. There's like the intuitive clunky way, and then there's the way using the semantics I haven't told you yet. Let's do the intuitive clunky way of doing it first. You could do something like this. Function, add 3, version 2, x, y, z. You could do something like this. If x is equal to undefined, and you want to, oh, no, I'm going to leave it like that. I'm going to leave it like that, and you'll see why. And y is equal to undefined, and z is equal to undefined. Return 0. Or maybe even -1. I'm going to return -1 just to show you something. Else, these two, return x, else, else if you can see how much work this is. And you might be thinking to yourself, do I have to do this every single time for every single function? Behold, a version of the function which handles undefined. Now, let's load her up. Add 3 underscore 2. 1, we get 1. 2, we get 3. 3, we get 6. So that's working the way that we expect it to. If we provide no arguments, it gives us -1, which is the everything is missing condition, right? Here's a question. Ah, it didn't work. Ah, that's a shame. Undefined 0? Oh, interesting. Does not a number also equal 0? Ah, that's a shame. Anyway, I was going to do a cool thing, but it didn't work out. We'll just put 0 in there. So, okay. That's terrible. That looks terrible. That feels terrible. You should feel bad as you're writing that. Alright? The way that JavaScript likes to handle these types of situations is by using default parameters. So we can give these parameters default values which are not undefined. We can define these undefined values, right? You can't avoid the fact that it's inserting something, but you can at least control what it's inserting. In our case, in this function, we have a convenient default value which we can use. Anything added to 0 is the thing that you added to 0, right? Mathematical property of 0. We can use 0 as a default value. In this case, numerically, it works, right? Syntactically, the way that you do this is you put these little assignment statements inside of the function declaration line. I have now set default values for x, y, and z to 0. So, if we pull in, add 3, default it, no arguments, you get 0. If I put a 3 in there, you get 3, 3, 5, 3, 5, 7. There you go. Everything works as expected. Or does it? What happens if we, throw a string in there. See, the property of 0 being a thing that disappears only applies if you're performing addition. If that becomes concatenation, the zeros are suddenly there again. So, dynamic typing, the plus operation does different things depending on whether it's addition or whether it's a string. There's no, like, the input argument is not typed, so it could be either. But when you add the default value, you are assuming a type. When we put zeros in there, we were assuming that this was an operation on integers. But that doesn't mean that JavaScript can't use it for dynamic ways and put stuff in there that's not an integer, in which case the whole thing breaks. Oh, JavaScript, I hate you. You guys understand how this could be a problem, right? That this is like resulting in inconsistent program behavior, doing very basic things, right? All right. Serenity now. So, okay. So now that we've discussed all of that, let's discuss lambdas and anonymous functions. So, are you folks familiar with the concept of a pointer at all? A couple of you have probably heard of a pointer, right? So, I want you to imagine pointers in the following manner. First, your memory, your computer memory, is a great big array of boxes, right? Lots and lots of boxes. That's what memory is, right? So let's imagine you have a box, right? When you make it a variable, you put a label on the box. You're saying, this is my box now. Let's call it foo. All right? Functions are also held in memory. So over here, let's imagine that there's function memory. All right? Let's say we have add3 defined in function memory. All right? The pointer, the function pointer, is like an octopus. All right? An octopus with one tentacle. That tentacle reaches out through memory and attaches itself to the function. Function pointer. All right? So, the thing about this is that this is still a variable in JavaScript in a dynamically typed language, which means we could replace it with anything else at any time. Right? We could put the number 5 in there and we would kill the octopus. The octopus would die and fall out into, wherever data that's been deleted from a computer goes. Presumably, in an alternate dimension, it's just like a giant trash heap of numbers from all of the numbers we keep killing in our computers. But, so that's the idea of a function pointer. We have a variable. It is touching an actual defined function. We can access that function and call it through that function pointer. but this is also just a variable. Okay? So, how do we do this? We can do this by declaring a function with no name and then assigning it, well, let's back up a step. Add 3, right? Add 3 is a function. Let q, or foo, equal add 3. I have now defined a function which touches the add 3 function called foo. I can call it as if it were add 3. I have duplicate references to the same function. If I ask what foo is, it says it is this function. Does that make sense? So you can assign functions to variables. Okay? So, so this kind of separates out the definition of the function from the naming of the function, right? So this is an important point. There we go. So I define, this is a slightly different way of defining functions than we've seen so far, right? The way we define functions over here, we say function, function name, arguments, content. Over here, we say create variable, assign function with no name, the rest of the function. These two ways of doing things are exactly, like those are identical. JavaScript does not recognize a difference between this way of doing it and that way of doing it. But this is an anonymous function. Before we assign it to the variable, this is an anonymous function, also called a lambda function. There are two different ways of doing lambda functions in JavaScript. The kind that we saw earlier with the for each loop, and this way of doing it. They're both exactly the same thing. Right? So, in JavaScript, we will need to define variable, we're going to have to define functions in place, not give them names, pass those to other functions as arguments. We will do this frequently in JavaScript. This is how we set up events, both timing events and like click events on DOM elements from JavaScript. So this is a thing that you will actually have to wrap your head around how to do. But perhaps not today, as class is now finished. Thank you very much for your time and attention, folks. We shall resume next week.